everyone, my name is Colin here with 3D Infotech to show you some cool features with SCANTECH's 3D scanners. Today we're going to be using the Nimble Track in order to demonstrate the dynamic tracking feature. Dynamic tracking is a feature that accounts for movements and vibration during scanning. It's great for environments such as factories or the shop floor where there's heavy vibrations such as a forklift driving by and moving your tracker in the part you're scanning. Dynamic tracking takes this into account in real time and allows you to keep your scan accurate without compromising your scan data. Additionally, it's great for larger sized parts because you're able to complete the part in one scan as opposed to taking multiple scans and splicing that data together at the end.
Dynamic tracking works by tracking markers that were accounted for before you start scanning. These markers need to be seen by the tracker while you're scanning, as that is how dynamic tracking accounts for movement and adjusts in real time during your scan. With the scan of the forklift, we want to get the front and a little of the sides. Once we have gotten the data we need on one side, we can move the tracker to the other side and continue scanning with no interruptions, and the scan picks up right where we left off. That's a dynamic tracking feature, which accounts for movement and vibration in real time to keep your scans accurate. If you have any questions, feel free to reach out to me or the rest of the team here at 3D Infotech.
Everyone, my name is Colin here with 3D Infotech to show you some unique features with SCANTECH's 3D scanners. Today we're going to be using the Nimble Track to demonstrate the Super Coordinate Conversion feature. Super Coordinate Conversion, or SCC for short, simplifies scanning medium to large size parts. Traditionally, when scanning large size parts like this car, we would need to put markers all over the car, or we would need to get multiple scans with overlapping data to then splice together those multiple scans at the end. With Super Coordinate Conversion, we're able to eliminate the need for the excessive markers and use just a couple markers and shared point cloud data in order to accurately splice together those scans in real time. This saves you markers and saves you time with splicing together at the end. The minimum amount of markers required for SCC is 4. However, here at 3D Infotech, we recommend going with 8 for better reliability. Here, I've got an 8-sided puck with markers on each side. We'll set that on the roof of the car, get the Nimble Track going, and we can scan.
We are going to start off by scanning the car as normal. Once we are done collecting the data, we'll switch scan modes to collect the markers only. Next, we can pause the scan, move the tracker to the next desired position, and then enable SCC in T-Viewer. Now we'll recollect the markers and switch back to laser scan to keep scanning. We want to make sure that there is overlapping data, as SCC uses the markers as well as shared point cloud data to stitch the scans together. Now repeat these steps as needed for the full part. Once all the data is collected, disable SCC and you now have your completed scan.
That's the Super Coordinate Conversion feature, a user-friendly feature that allows you to scan medium to large size parts with fewer markers used and saving time with splicing those scans together. If you have any questions, feel free to reach out to me or the rest of the team here at 3D Infotech.